So section 4.5 is all about the word problems. Either we're going to have an exponential. The word problems, you were supposed to print off those pages like I asked. So if you did not, I would definitely pull up your book and look at those as we go, because I won't always be able to show them since I'll be having to write as well. So I would somehow have the exercises set 4.5 printed off. So let's go and look at just number 1. And it says the exponential model describes the population of the indicated country A in millions T years after 2010. Use these models to solve. Well, if you look at India, it's A equaling that amount, e to the 0.008 t. And all of the other equations are in that form. Well, that equation should look very familiar to you. It should look like the formula A equaling PE raised to the RT. But we're not going to call it P in principal and amount because we're not talking about money. So the formula now is going to look like A equaling A naught E to the KT. A naught is just the initial amount. So A naught is just your initial amount, and K is just the rate. So it's the same formula as PERT, but it's going to be rewritten with different letters. So if I'm looking at number 1 and it says what's the population of Japan? Well, Japan's going to be A equaling 127.3 e to the negative 0.006 t. Now when it says what's the population of Japan in 2010? So what was the population in 2010? Well, looking at what this says, it says this is in millions T years after 2010. So if I'm doing 2010 and I'm starting in 2010, that means T would be 0. And anything to the 0 power is 1, so I would end up with 127.3 million. So that is your initial amount. So depending on when your equation starts, your initial amount would be the A naught. So I really didn't even have to plug in T being 0. So what is India's population? Well, it would be 1,173.1 million starting in 2010. Iraq would be 31.5 million. In Japan, we just figured out, and Russia would be 141.9 million. Now let's look at number 3. Which country has the greatest growth rate, and by what percentage is the population of the country increasing each year? So a growth rate, that would be your K, which is your rate up here. This one is a positive, this one's positive, but this one's negative, and this one's negative. Meaning what? Their population is decreasing, and India and Iraq, their population is increasing. So which one is the biggest? Well, putting that back into decimal form, putting it 2 to the right, we would have 0.8% for India. And Iraq would be, again, 2 to the right, would be 1.9% for Iraq. So which one has the biggest growth rate? 1.9% for Iraq. And again, the other two populations are decreasing. All right, so now let's look at number 5. Number 5 says, now when will India's population be 1,491 million? So we need to pick India's population. So it's A going to equal 1173.1 e to the 0.008 t. Now, what information are they giving us in number 5? We want to know when will India's population be 1,377 million, and we're trying to solve for t. So we're going to have to put in our A value and solve for t by using our strategies from section 4.4. So we're going to say 1377 equals 1173.1 e to the 0.008 t. So what do we do to start this off? Well, we most likely need to get the e by itself, so we're going to divide by 1173.1 on both sides. And here's the problem. A lot of y'all want to type that into your calculator, but you can't. You can't do anything with your calculator till you get t completely by itself, because you're going to start rounding way too early and then it's going to throw off your answer. So we're going to keep this as a fraction. So we have 1377 divided by 1173.1 equals e to the 0.008 t. So don't touch your calculator yet. Then we're going to do the circle. This is exponential, so I like to do strategy 2. So log base e of that fraction equals the exponent. So log base e of that fraction equals the exponent of 0.008t. Now we don't call it log base e. We know log base e is natural log, so it's the natural log of 1377 divided by 1173.1 equals 0.008t. So remember, you're doing the log of that fraction. And then we got to get t by itself, so we're going to divide by 0.008 divided by 0.008. So be careful how you type this into your calculator. So looking at our calculator, we're going to have the natural log of 1377 divided by 1173.1, close the parentheses because that's going to close your fraction. You can even press enter if you'd like, and then divide by 0.008 to make sure you take just the natural log of that fraction. And so let's go ahead and round to, let's say the whole year, so approximately 20 years. So it's going to take approximately 20 years for the population to reach that. Now what did it ask for? It said, when will India's population be that? So since this started in 2010, this will happens in 2030. Why? Because our formula started in 2010, add that together, and we get, it would happen in 2030. So I would try some of those other problems, but that's kind of how we're going to start with that one. All right, let's look at number 7 now. In 2000, the population of Israel was approximately 6.04 million, and by 2050, it's projected to grow to 10 million. Use the exponential growth model, a equaling a naught e to the kt, in which t is the number of years after 2000, to find an exponential growth that models the data. All right, so they did tell us to use the exponential growth model, so that's pretty much what we're going to use every time. So a equaling a naught e to the kt. Now look at when this is happening. It's starting in 2000. So the population of Israel was approximately 6.4. So my initial population is 6.4. So 6.04 million e to the kt. And what is a? Well, we know that it's projected. There's a population of 6.4 million and will be in 2050 it'll be projected to grow to 10 million. So we started in 2000 and we're saying that in 2050 we're going to grow to 10 million. So my A is going to be 10 million when my T is 50. Because from 2000 to 2050 is 50 years. Now why do I want to do this? Because I was not given the rate. So I need to find k to find my growth rate. So that's the first step in this problem. We're going to divide by 6.04. Again, don't touch your calculators because you need to not round to the very end, and 50 times k is 50k. So we're going to do the circle. Hopefully you're really good at it by now. Log base e of 10 over 6.04 equals 50k. Then what do we need to do? Well, we don't call log base e, we call it the natural log of 10 divided by 6.04 equals 50k. And then we're just going to divide by 50 on both sides to get k by itself. And so what is our growth rate going to be approximately? So we have the natural log of 10 divided by 6.04 divided by 50. So that's the growth rate, which is approximately, let's just round to 0.01. So approximately 0.01 is the growth rate. So what is going to be my exponential function? It's going to be a equaling a naught was 6.04 e to the k, which is 0.01 times t. Now they might want k as a growth rate, so you change it to 2 decimals to the right, so k would be 1%. All right, so we have our formula, A equaling 6.04 e to the 0.01 t. And now what is it asking us? It's now asking us to find what? In which year will Israel's population then be 9 million? So part B is when will we hit 9 million? So we're going to put 9 there. So 9 for A equals 6.04 e to the 0.01 t. So once you do these, you'll see it's the same step over and over again. Divide by 6.04. So we get 9 divided by 6.04 equals e to the 0.01 t. Then we're going to do the circle, which says log base e of that equals that. I'm not going to put log base e anymore. I'm just going to put ln. So ln of 9 divided by 6.04 equals 0.01 t. And then just to get t by itself, I'll divide by 0.01. So when will our population be 9 million? We're going to take our natural log of 9 divided by 6.04. And then if you want to press enter to get what that is, then divide by 0.01. And it looks like it's going to be at approximately 40 years. So we're round to the nearest whole year. So approximately 40 years. So since this equation started in 2000, what year will it happen? So plus 2000, it'll be in year 2040. So that one's a little bit more tougher because they didn't give us an equation that just had everything already in there. We had to use the information given to find out what our K was. All right, so now let's look at 15. So an artifact originally had 16 grams of carbon-14 present. The decay model, A equaling 16e to the negative 0.000121 t, describes the amount of carbon-14 present after t years. So we know that A equals 16e to the negative 0.000121 t. We like it because they gave us an equation. So then, on number 15, it says, how many grams of carbon-14 will be present in 5,715 years? So when t is 5,715, the amount left. So that one's kind of nice. All you got to do is plug in your t and use your calculator. So A is going to equal 16e to the negative 0.000121 times 5,715. So we have 16, bring up our e, negative 0.000121 times 5715. And we're going to see that we have approximately 8. So we have approximately 8 grams left. So why are we doing this problem when it was pretty straightforward? Because I want you to realize we started with 16 grams and we're down to 8 grams. So that means the half-life for carbon-14 is 5,715 years because it took that many years to go from 16 down to half. Which means if we double this again, the years, it's going to take another 5,715 years to go down to 4 grams. Then another 5,715 years to go down to 2 grams. And so that's what the next ones are wanting you to do. So after 11,430 years, you're going to do the same thing. So we just want to realize that the half-life is how long it takes for half of the amount to disappear. And it's never going to be completely gone because there's always going to be a trace left, but it's just going to be half every 5,715 years. So carbon-14 dating is pretty cool because it will be able to tell you how old something is. So, all right, let's try another problem. Let's look at number 19. Actually, let's do 20. I'll do 20 since you'll have the answer to 19 in the back of the book and you can try 19. So let's go ahead and try 20. So skeletons were found at a construction site in San Francisco in 1989. The skeletons contained 88% of the expected amount of carbon-14 found in a living person. In 1989, how old were the skeletons? So it did say to use the exponential decay model, A equaling A naught e to the negative 0.000121 t. So we are going to use the exponential model. Now, we have some skeletons that were found. and we do know that this was back in 1989. We want to know how old they were, but all we know is that they had 88% left. So we don't know the time, we don't know A naught, but we do know, in a sense, A. We know that it was 88%, but 88% of what? You really got to understand about percents. Percents are never just going to be written by themselves. We had 88% left. So it's going to be 0.88 times A naught. If the original amount was, say, 16, and you had 88% left, you would multiply 88% times 16. But because we don't know the original amount, the amount left is just 88% still multiplied by the initial amount. And we still have negative 0.000121 t. So make sure you really understand why I'm multiplying 88% times the original amount. Again, they didn't tell us the original, so since we don't know the original, we call it A naught, but we do know we had 88% left. 88% of what? The original. So now, just like on all of the problems, we want to get E by itself, so we need to divide by A naught, and look what happens. The A naughts cancel. So we get 0.88 equals E to the negative 0.000121 t. And then we're just going to do the same steps, solving a log equation, exponential, changing it into a log equation. I'm going to say log base E, log base E equals negative 0.000121 t. And then all I need to do is divide by negative 0.000121, divide by negative 0.000121. Again, make sure you type this correctly into your calculator to get the right answer. So we're going to have the natural log of 0.88, close it, press enter if you want to get what that answer is, divided by negative 0.000121. So we see that back in 1989, they were approximately 1,056 years old. On the test, I will tell you where to round. Sometimes they tell you, sometimes they don't. So we have 1,056 years old. So they were approximately 1,056 years old. So the percent ones are not so bad once you get down to understanding that you're just going to always do the percent times the original amount on that left-hand side to say what A is. So let's try another one like that. So go down to, say, let's do 31. Xanax is a tranquilizer used in the short-term relief of symptoms of anxiety, and its half-life in the bloodstream is 36 hours. How long will it take for Xanax to decay to 90% of its original dosage? So this one is a lot like the one we just did, but they did not give us as much information again. So we're kind of building on that one above. So we know we're going to use A equaling A naught E to the KT. But the problem is, in the previous problem, they told us what K was. In this problem, they're not telling us what K is. So we're going to have to use some information to find out what K is. So we talked about what half-life meant. Half-life meant it takes that long for half of that amount to remain. So if you look at number 31, it says that the short-term relief for Xanax, the half-life in the bloodstream is 36 hours. So one more formula you need to memorize. When you're talking about half-life, K is going to be the natural log of a half divided by the half-life. So when K is not given to you, when you're talking about half-life, you can find K pretty easily by just doing the natural log of a half divided by the half-life. So in this example, we know that it said that the half-life was 36 hours. So we get the natural log of a half divided by 36, and that'll give us our rate. So we end up with the natural log of 0.5 divided by 36. So we get negative that for our rate. What I want you to do is go out to 3 decimal places past all the zeros. So I have a 0, and then I have 3 decimal places past that. So I'm going to go to the 2, and I'll round because it's a 5. So negative 0.0193. So K is going to be approximately negative 0.193. So now I know what K is, whereas before K was given to us. Here I have to find K. So A equaling A naught e to the negative 0.0193 t. And now I can solve the problem. What's it asking? It says, all right, so if its half-life in the bloodstream is 36 hours, got that. How long will it take for Xanax to decay to 90% of the original dosage? So again, 90% has to be left. Of what? The original. Since we don't know the original, we're going to still take 90% of A naught, equaling A naught e to the negative 0.0193 t. So just like the problem above, we're going to divide by A naught, so those cancel. So 0.90 equals e to the negative 0.0193 t. Then we're going to do the circle to change exponential into log. Log base e we call natural log. So natural log of 0.90 equals negative 0.0193 t. We gotta get t by itself, so divide by negative 0.0193, divide by negative 0.0193. Once you do these, it's pretty much the same steps over and over again, but there is sometimes a little bit of information you have to find. So natural log of 0.9 divided by negative 0.0193. So after, how long will it take for the Xanax to decay to 90%? It's going to take approximately 5.5 hours. So it'll take approximately 5.5 hours. So I will do some more problems on the next video, but I want to give you time to think about these first, and then we'll try a few more.